So today we're going to be going over graphing piecewise functions. So we learned what piecewise functions are. We learned how to create the equations from the graph. Today we're going to start graphing it. Okay. So I'm using really simple functions today as our pieces. Okay. So that it makes it a lot easier for us to do. So these are my steps when I graph a piecewise function to help you out. Okay. The first thing we're going to do, just like we've done in the last 2 days, is I'm going to come over here to my domain where my domain breaks are. So this part right here, these, and anywhere there's a break in my domain, I'm going to put that vertical dotted line there. Okay. So for instance, this here, I have this -2 and I have 3. So I'm going to come over here to my graph, and at -2, right here, I'm going to put a vertical dotted line. And then I'm going to do the same thing for 3. So 1, 2, 3. I'm going to put this dotted line. Now, what that's doing for me, it's separating my functions or my equations. So I am going to have to draw 3 pieces. Okay? I'm going to have one piece on the left, one piece in between, and one piece on the right. Okay? So for instance, this graph right here, 2x plus 1, is going to show up where x is less than or equal to -2, which means it's going to be on this side. So I'm using red. Okay. Now this one, the blue one, is in between, so it's going to show up between here and here. And then my last one, what do I want to do? I could do it, let's do it in green. The green is going to be on this side. Okay? So basically what those lines are going to do is tell me where these graphs are going to show up. And if your graph goes over that line, you're doing something wrong. Okay? So let's start with the first linear function. We're going to start with the linear function, the red one. Okay? So again, the easiest way to do or graph a line is using y equals mx plus b. So I know my y-intercept is at +1 and my slope is 2. The problem is +1 on the intercept is here in the middle. So I'm going to make a very light mark there. Okay? Because that's where it is actually going to intersect. So now I can actually use my slope if I wanted to. The easiest way to do this, though, is just like we did with our warm-up today. I'm going to first plug -2 into my function. So I'm going to f of -2. When I plug -2 into my function, I'm plugging it into this equation, the 2x plus 1. And I get 2 times -2 plus 1. Right? And 2 times -2 is 4. -4 plus 1 is -3. So that's telling me that at -2 on this line, my line is at -3. So 1, 2, 3. Now, is that going to be an open circle or a closed circle? Closed, because it's equal to. So that's a closed circle right there. Okay? Now, you can see, because we made this point, if I use the slope up 2 over 1, up 2 over 1, it does, in fact, hit where I need it to hit. The other thing is we can use it the other way to find another point. So if I go down 2 over 1, this is a point on my line. I go down 2 over 1, down 2 over 1. Or if you don't like using the slope, I could plug in another point. I just have to make sure that point is less than -2. So I could plug in -3 or -4 or -5. And technically, all you need are 2 points to graph a line, right? So there's my linear function, like this. And there's an arrow on that side. Okay? So the easiest strategy is to plug in the value on that line into that part, see where it is, and then go from there. Okay? So we're going to do the same thing with the blue one. Okay? Now, the blue one is a constant function of 6. Okay? Unlike other functions, there is no input-output relationship. The constant function doesn't care. Okay? It doesn't care what x is. The y value will always be what for this one? 6. So no matter what you pick for x, y will always be 6. So for instance, at -2, right here, at -2, it's going to be at 6. So 1, 2, 3, 4, 5, 6. So I put an open circle there. Is that going to be an open circle or a closed circle? Open, because this is not equal to. So that's an open circle. Now I'm going to do the same thing at 3. Okay, so I go to this line here. And where is the blue function going to be at? 1, 2, 3, 4, 5, 6. Right there. And since it's the constant function, it just looks like that. There's the second part. Okay, so let's do the last part now. The last part is my third piece, which is also a linear function, -3x plus 10. I'm going to do the same thing I did so far. I'm going to plug 3. I'm going to plug this value into my equation. When I plug 3 in here for x, what is my y value? Well, 3 times -3 is -9, and -9 plus 10 is +1. So on this line, my function is at +1. Is that going to be an open circle or a closed circle? It's a closed circle because it's equal to. So I fill that in right there. And then again, I can either use the slope, which is -3, and go down 1, 2, 3 over 1 to get my next point. 1, 2, 3 over 1. Or I could plug in, say, 4. Is 4 greater than or equal to 3? Yeah, and if I plug in 4, 4 times -3, it's -12. -12 plus 10 is -2. And see, that's that point right there. So either way, I can get these points, and I draw my line, and that is my piecewise function. We're done. So if I had to give you guys steps, okay, if I said, hey, what is the procedure that we're doing for piecewise functions? Step 1, plot your breaks in domain. So first you're going to plot the breaks in your domain. Whatever number shows up here in your domain, you're going to put those vertical lines. 2, plug the breaks into the equations. So the first thing that you're going to do after you draw those lines is like we did here. We plugged -2 into this function to find out where it was on this line, this point right here. We did the same thing for this one and this one and the green one. We plugged 3 into the equation to find where it is on the line, okay? Because in order to find where it is after that, we need to know where it's starting and where it's stopping, okay? So plot the breaks in the domain, plug in the breaks into the equations, and then 3, graph the pieces. And then for that part, you can either use your transformations or you can plug in coordinates, points, whatever you want to do this part, okay? Whatever you feel comfortable doing, okay? Those are the 3 steps that we're going to do every single time we do a piecewise function.